Okay, so today I will finish up the demonstration that we were working through on Monday, and then I want to bring in a few more kind of techniques. Okay, so you can follow along on your laptops if you want, or you can just kind of watch me do stuff as I explain. And so on Monday, I want to do a demonstration of just, taking a data set, calculating the mean for, one group, the mean of another group, and then actually doing a statistical test to compare those two groups. So the data set that we are working with is this Las Vegas hotel reviews data set. And one could argue maybe it's not a representative sample, maybe it is, I don't know. But within that data set, we have different star classes of hotels. So there are, 3-star hotels, 4-star hotels, 5-star hotels. And I want to know is the the rating score that a customer leaves, is it different for 3-star, 4-star, 5-star hotels? And so I walked us through that by doing different t-tests, okay? And so I'm going to just go ahead and run all of the code. It loads up our Las Vegas CSV data file, and we can compare, say, the scores of 3-star hotels versus the scores of 5-star hotels. We do a t-test, and what we find is we get a p-value of, say, 0.0005. The threshold that we compare against is 5%. Our p-value is less than 5. So that means we have evidence, our data provides evidence that there actually is a difference between these two means, that the difference between 4.02, which is the mean score for 3-star hotels, and 4.38, which is the mean score for 5-star hotels, these means are statistically different. Okay, and again, kind of the root question we're always going after is it possible that we got this difference by random chance? And according to our calculations, while not impossible, it is very unlikely. It's very unlikely to get this difference by random chance. So therefore, we conclude that there actually is a difference between 3-star hotels and 5-star hotels as far as scores go, and the result is not because of random chance. And that's fine. I think to do 3 t-tests when you're comparing 3 groups, 3 versus 4, 4 versus 5, and 3 versus 5, that's fine. Okay. However, if you have a bunch of groups, okay, and so this is going to be different for everybody's data set. So, but if you wanted to compare the means of a bunch of groups, let's say you had 6 groups, I would recommend that you do not do a bunch of pairwise comparisons, because if you do pairwise comparisons, there's going to have to be a total of 15 of these comparisons. And when you run a whole bunch of comparisons, you're much more likely to kind of flag. You greatly run the risk of flagging that there is a difference when there actually isn't one, right? So you're going to kind of get a false alarm type of situation where you're going to think, oh, there's a difference between group 2 and group 5. But in reality, there's not actually a difference between group 2 and group 5. It's just random chance. But because you did so many of these things, and every time you do one of these things, there's around a 5% chance that you get a false positive. Okay, you do 1 test, 2 tests, 5% chance of a false positive. We're not too worried about it. But if you do like 20 of these things and there's a 5% chance of a false positive, there's a decent chance that one of the, like, let's say you have, you raise a red flag on one of these things, there's a decent chance that that red flag could have just been a false positive. Okay. if you're going to do a whole bunch of these things. So doing a whole bunch of multiple comparisons at once, comparing multiple means at once, there is a different statistical test, and this is called ANOVA, okay? Analysis of variance. And if you are, I guess, a data theory major or a stats and data science major, one of the classes that you take is Stats 101B, which is called Design of Experiments, and ANOVA, or ANOVA plays a big part of it. And so you can take an entire class devoted to this topic of ANOVA. Here I'm just going to dedicate maybe 10 minutes to it, okay? Where I'm just doing the kind of the simplest example of ANOVA, where we have multiple means and we just want to compare them all at once rather than doing a whole bunch of pairwise comparisons. And so that is one simple case of ANOVA. ANOVA is very flexible and can accommodate a whole bunch of different kinds of data scenarios where, you know, you did like a before and an after study, and you had these different groups, and you randomized this group and things like that. And so you can definitely extend ANOVA for all of these different scenarios. The simplest situation for which you are going to apply ANOVA is going to be this one, where you have groups, you've got means of different groups, and you want to compare them all at once rather than just doing two at a time. Okay, so a t-test, you're comparing two groups at a time, and it's very much limited to two groups at a time. But if you have, say, 3 groups, 4 groups, 5 groups, and you just want to compare all of the means all at once, you can use ANOVA for that. But yeah, again, there's so many more scenarios, and you can always ask the internet, like, oh, how do I do ANOVA for this and that? Am I still amplified? I'm getting a low battery warning here. I think I hear myself. Okay, all right. Okay, so what do we have? Okay, so ANOVA is a statistical test used to compare the means of 2 or more groups simultaneously. It helps overcome the multiple comparisons problem by just first asking an overall question: is there any significant difference among the means of any of the groups? Okay, the kind of the shortfall of ANOVA is because it's saying, is any of these different? If the answer comes back to be yes, something's different. The only unfortunate thing about ANOVA is it doesn't tell you which one's different. It just goes, they're not all the same, and that's the end of it. Okay, so we are going to compare groups based on one factor or one variable. In our case, it's hotel stars. And so our null hypothesis is that the average scores for all of our categories are equal, that the average for 3-star hotels, 4-star hotels, and 5-star hotels are all equal. And then the alternative is at least one of the group means is different from the others, okay? And again, it is not going to tell us, is it that the 5-star is different from the 3 and 4-star, or is it that the 3-star is different from the 4 and 5, or is it that the 4-star is different from the 3 and, it's not going to tell you which one, okay? Hotel stars is going to be treated as categorical because these are distinct categories, not a numeric variable, and we talked about that. There's no such thing as a 3.1 star hotel or a 3.7 star hotel. There's kind of some in-between categories of like 3.5 star, but anyway, it's not really numeric, okay? All right, and so the way we would do ANOVA is we say, all right, this is the score that we're looking at, and we're going to look at hotel stars, and we have to type this thing kind of in this slightly awkward way. We write score tilde, basically the variable. So we're going to say score, this tilde here is kind of like explained by this variable. So we're going to say, can you analyze the score output based on which, like the hotel star rating, okay? Our data is the Las Vegas data frame, and that produces our ANOVA model. And then we will ask to kind of give a table of our results and we will do summary of the ANOVA model. Okay, so we take AOV, analysis of variance, we store that result into ANOVA model, and then we will ask for a summary of this. So I'm just going to click the little play button here, and it says this, okay? And basically, the number that we're most interested in is the rightmost number. This is our p-value, okay? There's other things in here, and I have a brief explanation of each of these things. I would not worry too much about it right now because, again, this is just an intro class and we're not going to focus on the details of the ANOVA, okay? But the different columns here, you have degrees of freedom, DF. You have sum SQ for sum of squares. You have mean SQ, which is mean squares, which is the sum of squares divided by the degrees of freedom. And then you have the F value, which is going to be the mean squares divided by our residual mean squares, okay? And then when you look up the value in, say, a reference table or something, you get the p-value. And this is the number that we're interested in. So we have 1.09 e minus 0.5, or 1.09 times 10 to the minus 5. So that's going to be 0.0000, 4 zeros, then 109. And this is the probability of getting our data, or something more extreme, if the null hypothesis were true, okay? And so our p-value, this being 0.0001, is much smaller than our significance level of 5% for alpha, and so we're going to reject the null hypothesis, and our ANOVA indicates that there is a statistically significant difference in the average customer review scores between 3, 4, and 5-star hotels. Okay, and that's it. All we're going to say is that, yep, there is a difference. And again, the limitation is that it's just at least one of the group means is different, but it's not going to tell us which of the specific pairs. Okay, is 3 different from 5 or 4 different from 5? And for that, you would have to do basically our multiple t-tests or something like that. So it feels like, oh, well, what was the point of that? Again, I would say the approach, if you have a whole bunch of groups, okay, like 5 or more groups, do a one-way ANOVA first, see if there's a difference. If there is a difference, then go ahead and do a bunch of t-tests, okay? And probably just start by doing like the group with the highest average versus the group with the lowest average. And that one will probably come out to be significantly different. But if you just start off with doing a whole bunch of t-tests, you run the risk of flagging something that doesn't actually exist. Okay, so that is that's our example of one-way ANOVA. Okay, let me give you your first view quiz answer. First view quiz answer today is the letter D. D as in dog. Okay, D as in dog. Okay. A student asked, like, is this how I want you to do your project? And the answer is not necessarily. I think what I'm going to be doing in like the coming lectures is I'll be taking like different data sets and just doing some different kind of analysis techniques that you may or may not want to use for your particular project, right? So everybody's doing a project with a different set of data. So everyone's kind of circumstances will be different and unique. And so for your particular data set, perhaps ANOVA is appropriate, okay? And for your other people, their data set, ANOVA is not going to be the appropriate test to use, okay? Maybe a t-test is perfectly adequate, and for other people, the t-test is not going to be what they use. So I'm just kind of showing you like, all right, this is one thing you can do if you have this kind of situation, right? And the situation here is you have different groups, you have a numeric output. In this case, it is the score rating. The score rating, the score is like the customer score that they're giving the hotel. That's a numeric value, and we're comparing the means of these numeric values. Okay. I have this second RMD file, all right, and this is also posted. I have lecture week 6 L2, techniques for text and factors. And so this is what we have here. So this is just kind of further analysis on the Las Vegas TripAdvisor reviews data set. And here I'm going to do a couple things. One is going to be a set of text operations, and another is going to be dealing with the categorical variables, where we have like the month and the day of the week. Now, in the context of this particular data, the text operations don't really make any kind of sense as far as like something that somebody would actually want to do in there, or I guess some of these text operations. Some of the text operations do make sense, but then some of them, like, it wouldn't actually be useful. However, for your data set, whatever it might be, some of these text operations might be what you want to do. So I just kind of wanted to show a demonstration of like how you would go about doing something like this. You can further look up, more tools to do it, and you can do that. So let me just kind of start off here. So I guess I'll start by kind of clearing my environment. But first we'll kind of load in our data again, and we use Janitor to clean the names because I like having the cleaned names. And so again, the names of our names of our data frame have been adjusted to this. Okay, all lowercase with underscores. And what we're going to do is we are going to create some new variables. Okay, and the way there's lots of ways, but I like to use the tidyverse, and the way we create new variables in the tidyverse is using mutate. And whenever you do this, one note is that after you create, actually, you should test out creating your new variable, and to kind of just verify that the new variable actually does what you want it to do, I suggest viewing the output. Okay, and if the variable is indeed created the way you want it and expect it to work, then go ahead and save that output, that change. Okay, so my conceptual example is, let's say you have your Las Vegas data set, you have some kind of old column, and you want to do some kind of operation with it to define a new variable, and that's going to be our new column. What you want to do is you want to verify that this is actually doing what you think it should be doing. And so after you mutate that, you want to kind of select both the old column, the new column, so you can kind of see, does this look like how I want it to? And then view it. Okay. Now this operation doesn't actually save any of the variables to Las Vegas. Okay. The only way you actually save something is you need that arrow that saves it. Here it's just take Las Vegas, do this, and mutate create a new variable. Let's take a look at it. Okay, it doesn't actually save it anywhere. But then after you view it, if it looks good, then go ahead and save it. So what we're going to do is we are going to use this function called string detect. Okay, and it's gonna, what this thing does is it takes a character column, a column of like strings, and it tries to look for certain patterns. Okay, so some of your data sets have a column where it's there's a lot of text. Okay, so if you're dealing with like a movies data set or something like that, okay, you might have a column where it's like the title of the movie, or you might have a column for the name of the director, or a column where it's like the name of an actor or something like that, right? You have this text and you want to kind of search for a certain word, right? So maybe you're like, I don't know, maybe one of the columns is like, I don't know, you're going to search for Harry Potter, or search for Marvel, or search for something like that, right? And you want to search for this thing. So here we're going to use string detect, and if it detects that particular word, it will say true. And if it doesn't detect that word, it's going to say false. Okay, so in our data set, some of the, these are our hotel names. We have Circus Circus Hotel and Casino, Excalibur Hotel and Casino, okay? And we have Tropicana Hotel, Caesar's Palace, there's the Cosmopolitan and whatever. Okay, so there's actually a casino in the Cosmopolitan, but here I want to know, like, okay, let's see if we can detect the word casino in the hotel name, okay? And so what we are going to do is under string detect, okay, the column we are searching is hotel name, and the pattern that we are going to search for is casino, okay? So we are going to create a new column called has casino, and this is going to be a column of either true or false, and it's going to be the result of trying to string detect within the hotel name if it has this word casino. Now it is text case sensitive, so in our case casino is with a capital C, and we're going to do that. And then again, we want to just verify before we actually save the results. We want to verify, so we're going to just click, we're going to say select hotel name and the column that we just created has casino, and then we're going to click say view it. Okay, so we pipe that into view. And so I'm going to just run this, and this is the output. Okay, and this is the output, and we want to say, okay, Circus Circus Hotel and Casino comes back and says true, and that sounds about right to us. Okay, Excalibur Hotel and Casino comes back as true. And then, you know, we kind of keep going, and we see, okay, Tropicana Las Vegas, a DoubleTree by Hilton Hotel. That doesn't have the word casino in the title, so that comes back false. Caesar's Palace doesn't have the word casino in the title, so it comes back false, so on and so forth, okay? It should be has casino in the title, because the Cosmopolitan, Caesar's Palace, they definitely do have a casino at the property. But is the word casino in the hotel name? It is not, okay? The Palazzo Resort Hotel Casino, that does have the word casino in there. So anyway, now we have has casino is true or false, and we can then use that to, you know, have, you know, does it make a difference if the word casino is in the title of the hotel? Maybe, maybe not. Okay, now, I guess if you're going to do something like this, make sure that the analysis makes sense. In the context of this particular data set, using the word, searching for the word casino in the hotel name doesn't actually tell us if the hotel actually has a casino or not. Because again, I've been to Las Vegas, and I know Caesar's Palace definitely has a casino, but in the data set, it's not Caesar's Palace Hotel and Casino, it's just Caesar's Palace, okay? And so using that word, does it have casino, as an indicator if it actually has a casino or not, is not going to be an accurate and reliable detection method. So make sure the operation actually does make sense. So in this case, it would be, I would say, you know, as nice of an operation this is, it would be incorrect to then carry forward the analysis and say, because, you know, these are the hotels with casinos and these are the hotels without casinos, because again, it's going to improperly categorize Caesar's Palace and the Cosmopolitan as not having a casino when they do. Yeah, question.
In this case, when we're searching, we're just like, for example, you search casino within the hotel names. It's not like only the computer is only detecting within the column of hotel names if there's a casino where it happens.
Yeah, it is only searching that one column name that you've specified, in our case hotel name. So it's going to search in that column for whatever word or pattern you've looked at. Now, you have to be a little bit careful, because if you have like I don't know, like if you do like the word sort, okay, and if you're looking for that, it's going to detect SORT in resort, okay, it's going to detect, I don't know, just whatever it might be. Okay, so here I'm doing, say, casino, and so this is where I say having knowledge about the thing is important, because if you are not familiar with Las Vegas, you might be led to think, okay, well, hotel name, this one has casino, so they have a casino. When Las Vegas doesn't have the word casino in the title, so they don't have casino. But the Wynn has a casino. Okay. Meanwhile, Trump International Hotel does not have a casino. I'm not familiar with the Cromwell and stuff like that, but this is like Hilton Grand Vacations does not have a casino, so they don't put that in there. But there's different things, and the hotel name, as it's written in this data set, isn't enough to tell you about the casino. I guess this variable over here, casino. Oh, Hilton Grand Vacations does have a casino. Let's see, Trump International Hotel. I'm pretty sure. So it says casino. Yes. I don't think so. Yeah, the answer is no. Okay, does Trump Las Vegas have a hotel? And I don't think Hilton Grand Vacations. Pretty sure that one is also no. Okay, yeah. So I would say, so now I'm questioning the accuracy of this data set at all. Okay, because it's saying casino yes or no, and having been to Vegas, and some walked across some of these properties. Yeah. Okay. Yeah. Question.
If that happens, where the data is incorrect compared to like factual facts, are we allowed to go in there and manually change in the data set?
Yeah. So yes, and the question is, how many records do you have? And if it's like 1 million records, then how are you going to correct all of these things, right? And so you might say, okay, well, from our data, this column is no longer reliable, and I am making my own column of this. But yeah, if you only have a handful of records and you say, okay, I know this is not correct, you can just delete that thing or just change it, okay? And you might be able to go through the entire data set and do that. But if it's only like, I've detected a problem here, but there's 900,000 other rows, you don't really know if they are problematic or not, right? So if you know there is a problem with some of the data, now you have to worry, is there a problem with more of the data? That's always kind of an issue. Okay, all right. But anyway, let's say you are happy with the operation. Okay, and so, as far as like, does it detect the word casino in the hotel name? It does work, and we viewed it, and we're satisfied with the operation. So to kind of save this, now I do Las Vegas. We will run that same command, mutate has casino based on this, and then we have to store it back, okay, into Las Vegas. And you will see right now, if I click Las Vegas right now, it doesn't have the column has casino. Okay, it's still 20 variables. But now after I run this code, if I click the play button here and I run this code, now you will see in our environment, the Las Vegas will update from 20 variables to 21 variables. Okay, and you can see we do have that additional variable there, and I can click and view it, and we can see it now has this variable for has casino. Okay. Yeah. Oh, I don't know. I don't know how they got this column of casino. Yes or no. Maybe they looked for the word casino in the hotel reviews, and maybe somebody wrote like, "Oh, I'm glad the hotel does not have a casino," and yet it's like, I don't know how it works. Okay. But yeah, that's what you have there. Okay. Sometimes you want to look for different words. Okay, so for example, hotels owned by Hilton or Marriott often put in the word, they'll say like, this is the DoubleTree by Hilton, or this is, whatever, by Marriott, or things like that, an IHG hotel or something like that. And so here, if you have like different words and you want to say, I'm looking like, so here we're still using string detect, but if you're going to look for like multiple words, the way you would do it is you put in parentheses, and you're going to say, I'm looking for Hilton, and then you vertical line. Vertical line is usually above your enter key, shift vertical line, and then you put in the other words here. So this is going to search for Hilton or Marriott, okay? And so you can do this. And again, we want to just kind of see if this is working in the first place. And so if I want it, I'm going to mutate and then select those columns and just click View. And so here we are looking for the word Hilton or Marriott. And so we can see all of these are things, but we have Tropicana Las Vegas is a Hilton hotel. And that's true. What else do we have? Hilton Grand Vacations, Marriott's Grand Chateau, and those come back as true. Whereas the other ones, like the Encore at Wynn Las Vegas, comes back as false. And so that aligns with how we like it. And so if we wanted to save that again, doing the view doesn't save any of these variables. You would have to use this arrow and save it back into Las Vegas in order to do that. Okay. So that's another kind of operation that you can use if you are dealing with a column with text and words, and some of your data sets have text and words. Okay. There is another operation where you are extracting text. Okay, and here we can use what's known as a regular expression. And again, regular expressions, they can become super complicated. I'm going to just teach you the very basic things. If you have questions, and if you say like, I'm dealing with text data and I'm not sure how to build a regular expression, come see me during office hours. And also, I think it's okay. I give you permission. You can ask ChatGPT, help me write a regular expression that's going to perform this task. Okay, you can say, I have a column and I want to extract out like the numbers in the column or something like that. Okay, and ChatGPT is actually really good at dealing with regular expressions. And again, don't hesitate to ask me, and I give you permission to use, say, ChatGPT for regular expressions and things like that. Okay. But just some basic things. Again, you want to verify, like, does this do what I want? Okay. So you can put in a dot. This is going to be like any kind of character, a wildcard that matches any character. Curly brace n says I want this exact number of characters. Okay. And $sign means the end of the string. Caret means at the beginning of the string. So let's say you want to just draw out the last two characters in a particular column. Okay, and so, looking at this, again, it doesn't make sense to do it for this particular data set. But let's say I'm dealing with this column, number of rooms, and I just want to extract out the last two characters. So in this case, it would be 7-3 or something like that. That kind of analysis doesn't quite make sense. I mean, I could do weekday and just I want to extract out the last three characters. And then I would get, DAY for all of these things. Or maybe I want the first three characters or something. Or you can have something where you want to extract out, okay, so period of stay, like, for example, let's say I wanted to get the last three letters to get, like, which month it ended in, or, the first month or something. I don't know, okay? But if you wanted to extract out the last two characters, okay, the pattern we could use would be doing dot, curly brace 2, $sign. And this means I'm matching any character. Okay, the dot is match any character, and I want exactly two of them. So any two characters, and this is at the end of the string. So match any two characters at the end of the string. And if I want to pull this, I'm going to use string extract. String extract, we're going to take the number of rooms. R treats this as it's a numeric column, but we're going to treat it as characters, and I just say I want to take the last 2 characters. And so just to kind of test this out, again, before I save anything, I'm going to just view it to just verify, and does this look correct? So I click view, and we're going to look at this column number of rooms, and we extracted the last 2 characters, and indeed it extracted out 73 for that. Here we have 3981, and we got 81, 2884, and we got 84. So that looks like it's working correctly. Okay. If you want to do something at the beginning of the string, you would do caret. Caret means at the beginning of the string, and here I'm just going to say I want 3 characters, right? Any character, and I want 3 of them. So match the first 3 characters of the string. Again, just to kind of test this out, I can click view, and so for 3773, it extracts 377. 3981, it extracts 398, and things like that. So you can imagine having a data set where maybe you have phone numbers and you want to extract out the area code. Maybe you want the first 3 digits in the phone number or something like that, and you can do this. Okay, and yeah, I think, let's see, if I go to ChatGPT and I say, help me write a regular expression so I can extract the 3-digit area code from a column of phone numbers. Okay, let's see. ChatGPT is thinking. Here's a clear, robust. Okay, all right. Oh, and it's going to handle all kinds of these things, and it says we are going to search for an optional opening parentheses, a 3-digit, capture exactly 3 digits. This is the area code, and match an optional closing parentheses. Okay, and then it gives me code in Python, and I'll say, can you give me the code using string R in R? Okay, and it will update this. Okay, so at the risk, again, so ChatGPT is a tool that can increase your productivity. Don't over rely on it, because otherwise you will not develop the skills yourself, right? So there's a balance between doing these different things. Okay, so here is the example of different phone numbers. Here it is doing extract the area code. Okay, why is it doing? Okay, it's saying these are the phone numbers. This is the area code. Okay, so here it's running it twice. Okay, extracts the area code, possibly including parentheses, and then here extract, it says removes any parentheses if present, returning just the digits. And if you run it, it seems like it runs. Okay, and so this is a tool that I give you permission to use as far as like dealing with text. So these are things that you can do. Okay, other things is there is a function called table in R, and this will take a categorical variable, and it will kind of give you a tally summation of like how many of these things occurred. So here, as far as Las Vegas goes, one of these columns is review month, and we might be curious like how many reviews were done in each of these different months. Okay, and so we can use table, and so we're going to select just that column, review month, and we're going to do table, and it comes back and it says, oh, we got 34 from each of these things. And that is explained in the paper, the research paper that was used, where the researchers gathered this data. They say, hey, we went through and we picked 2 reviews from January and 2 reviews from February and 2 reviews from March. And we went through the entire, we went through TripAdvisor, and we intentionally just picked 2 reviews from each of these months. So that's why we have all of these things are exactly the same, 34, 34, 34, okay? Now, one issue is that ours default behavior is to put everything in alphabetical order. So the months in alphabetical order are April, August, December, February, January, July, June. And this is very disorienting to see the months written in this way, right? Written in alphabetical order. We don't like seeing our months written in alphabetical order. We want to see them in calendar order, okay? January, February, March. And so we don't like that, okay? Similarly, you can also create another table. You can select 2 columns, and it will give you what we call a two-way table, okay? And so here I can say, hey, deal with review month and the review weekday. So if you look at Las Vegas, you know, the reviews were written on, where'd they go? Okay, in August on a Saturday, in August on a Friday, in August on a Wednesday, so on and so forth. And we can go through and we can say, oh yeah, you know, in December, there were a lot of reviews written on Tuesday. I don't know, maybe that was Christmas that year. I don't know. Okay, and we also have, you know, only 2 reviews were written on Friday of December, okay? And in August, only 1 review was written on a Tuesday and things like that. So we have these different kind of reviews that we have here. And these are tabulated and counted up. And we would find, you know, a sum of 34 in each of these things. But again, the weekdays are in alphabetical order, which is Friday, Monday, Saturday, Sunday, Thursday, Tuesday, Wednesday, which, again, that's how we do our, you know, the weekdays in alphabetical order. We don't like them in alphabetical order. So we want to set the order. And so we are going to do this with factors. And we will set our levels ourselves, okay? I think I showed an example of setting the levels for an ordered factor last time as well, when we said, hey, I want to put the 5-star reviews at the top rather than at the bottom. Same kind of thing here. It's just we're going to take our review month, and I want to set the factors in alphabetical order. So my levels, I have to type this out manually. There's no way around it. But you have to say the order of the months is this: January, February, March, April, May, June, July, August, September, October, November, December, okay? R doesn't know this internally. It just knows alphabetical order. But as far as calendars go, this is the proper order. And so if I do this and I reset my review month this way, okay, I have to store it back into that column review month, so Las Vegas $ review month. I'm going to store it back in there. Then I can select that column and table it, and now our months are in the correct order: January, February, March, April, May. That feels better. Okay, I can do the same thing for the weekday, and then I can create this table, and now the table is in the correct order with the months in the correct order this way, and the weekdays in the correct order going that way: Sunday, Monday, Tuesday through Saturday. So we like that. If you want to add row totals and column totals, you take your table and you run this function add margins, and this will add the row totals and column totals. And so we can see, yep, 34 reviews in January and so on and so forth. We can also see the number of reviews for each of the different weekdays. And, you know, similar, but for whatever reason, not very many reviews on Thursday. But that's what we have. Okay. And so these are, you know, just some, I guess, techniques that could be relevant to your group's particular data set. Maybe different, may or may not apply. But if you are dealing with text variables, okay, these are certain things that you can do to kind of extract out or detect certain string patterns. And then if you have categorical variables that should go in a certain order, this is how you would adjust your data to fit that. Okay. How many answers have I given you? Just one? Okay, let me give you your last two. And they are D and A. D for your second answer, and A for your third answer. Okay, and that is it for today. I think everybody's signed up to meet tomorrow for their proposal meeting, and so make sure you submit your proposal questionnaire by 5 p.m. today. That is the deadline. 5 p.m. today is your proposal deadline, and then I will see you at your scheduled time. Yes?
Sorry, I just insert the number you said. What's the answer?
It's 2 points.
Is wrong?
Yeah.
Oh man. Okay, I gotta fix that. All right, I'll adjust it so it's BDA. Okay. Yeah.
Was it DD?
DDA?
Yeah, it's DDA.
I told you DDA?
Yeah.
Oh, okay. It was supposed to be BDA. All right. Okay. I'll. What did I say? D?
Yeah, DDA.
That's what I told you guys? Okay. I will adjust it so it's that. Okay. Sorry about that. I apologize. Yes. Okay. Make sure you submit your questionnaires. I will see you tomorrow on Zoom. Use my office hours link. And I guess I'll send an announcement to everybody. Use the office hours link. We'll meet you on Zoom for your proposal meetings, and I look forward to that. Okay. Good luck, and we'll see you tomorrow on Zoom.